Hey everyone, welcome back to the channel. 2026 has already been a pretty wild year when it comes to new climate research. It feels like every month there's another big study dropping, and a lot of them are pointing in the same direction. They're talking about the planet warming up quicker than we thought, some big ocean currents getting shaky, and more risks of these things called tipping points where stuff could change faster than we expected. A bunch of news outlets are turning this into super dramatic end-of-the-world stories, which I get. Those make for exciting videos and movies. But in real life, I like to slow down and actually look at what the science is really saying. Are all these studies agreeing with each other? What can we actually take away from them without freaking out or ignoring it completely? Let's dig into it together today. First off, the biggest question everyone's asking after these new papers: is the Earth really heating up faster than scientists predicted before? Well, yeah, according to one careful analysis that came out back in March from researchers Grant Foster and Stefan Rahmstorf. They published it in this journal called Geophysical Research Letters. Before we jump deep into the numbers, though, if you're enjoying these videos and want more like this, could you just hit that like button and subscribe? It really helps the channel out and only takes a second. Thanks. Okay, so what do the actual temperature records show? When they looked at the data, it seems like over the last 10 to 15 years, the warming has picked up speed compared to earlier decades. From the 1970s up to around 2015, the planet was warming at about 0.2 degrees Celsius every 10 years, but since then it's jumped closer to 0.35 degrees per decade. Now, that might not sound like a huge difference when you just hear the numbers, but if you draw it out on a graph, it's like the line suddenly gets steeper. Scientists are working hard to figure out exactly why this is happening. Some experts, like James Hansen, say a big part of it comes from cleaner air, especially over the oceans. Ships used to pump out a lot of dirty particles called aerosols from burning fuel. Those particles actually reflected some sunlight back into space, which had a cooling effect even though the fuels were causing warming overall. Now that shipping has cleaned up a lot and cities have less pollution too, that cooling mask is fading away and we're seeing the full heat from our emissions more clearly. Other scientists, like Professor Michael Mann from the University of Pennsylvania, think it's more about natural ups and downs in the climate, especially ocean patterns like El Niño that we talked about in an earlier video. He points out there have been a couple of strong El Niño events lately which can make things temporarily hotter. According to him, the long-term warming rate hasn't really changed much. It's still bad, but steady. He says the planet will keep warming at about the same pace until we stop adding carbon to the air completely. Then there are studies suggesting that maybe Earth's climate is a bit more sensitive to our actions than older models showed. All this back and forth can make your head spin if you're just a regular person trying to follow along. And of course, people who don't believe in climate change jump on these normal scientific discussions and act like it means the whole thing is fake or that scientists are lying. That's not fair, because even with some disagreements on the exact speed, one thing is super clear. We're still seeing record hot years, record hot months, and the trend is going up. The planet is definitely warming, and in many ways it's matching or even hitting the higher ends of what scientists predicted years ago. Now let's talk about something really interesting and a bit worrying: the AMOC. That's the Atlantic Meridional Overturning Circulation. Basically, it's this giant conveyor belt of ocean water that moves warm water up north and cold water down south. It helps keep Europe's weather milder than it should be for how far north it is. We've covered this before on the channel, but there's fresh research making headlines. A big new paper in Science Advances, led by a researcher named Valentin Portmann and his team, mixed real ocean measurements with computer models. They found the AMOC might weaken by around 50% by the end of this century. That's more than many older models suggested. They're not saying it's about to totally collapse tomorrow, but it might be closer to a dangerous tipping point than we realized. Other studies are starting to line up with this idea too. There's still some debate on exactly when and how fast, which is normal in science, but the evidence is building that this system is getting more fragile. Why does this matter so much? If the AMOC slows down a lot or even collapses, it wouldn't just be one small change. Places in West Africa that already struggle with drought could get even less rain. The Amazon rainforest, which is like the lungs of the planet, might dry out more too. On the flip side, some tropical areas in the southern hemisphere could see way more flooding. Farming would get hit hard in vulnerable spots. Northern Europe could get surprisingly colder winters, while the east coast of the United States might see extra sea level rise affecting big cities. These aren't small inconveniences. They could mess with food, homes, and economies in huge ways. What's even more eye-opening from recent papers is how all these different tipping points aren't happening alone. They're connected like a web. One change can trigger others. There's a really important paper from February 2026 on One Earth by experts, including Johan Rockstrom. They talk about tipping cascades. Imagine ice sheets melting and adding fresh water to the ocean. That fresh water can slow down the AMOC even more. A slower AMOC messes with how heat moves around the planet, which can lead to more warming, and around it goes. It's all linked. Right now, with the policies countries have in place, we're on track for about 2.7 degrees Celsius of warming by 2100. And just as I was working on this video, some early info leaked about the next big IPCC report. That's the big International Climate Assessment. And they've ditched that old extreme scenario that assumed crazy coal growth, which never happened. But even the middle scenario still looks pretty serious. If we don't cut emissions fast, we could push towards 4 degrees or more. At that point, these experts warn that economies and societies as we know them would struggle big time. They're not saying total disaster is locked in, but the risks of crossing multiple tipping points grow as the temperature rises. And regular economic models that governments use often miss these sudden changes. They assume everything shifts slowly and we adapt perfectly. But real life throws curveballs, big floods, long droughts, crazy heat waves that hit harder and faster than expected. Speaking of heat, that's what a lot of people feel first when they think about climate change. The latest European climate report is pretty stark. In 2025, almost all of Europe had warmer than average temperatures. Sea surfaces were the hottest ever recorded there. Marine heat waves were strong across most areas. Wildfires burned over 1 million hectares, a record. There was this long heat wave up in Scandinavia where temperatures near the Arctic Circle hit over 30 degrees Celsius. Glaciers melted a ton, snow was way below normal, and Greenland lost billions of tons of ice. These aren't just numbers on a page. They're things people are living through right now. None of this research says we're doomed for sure. But when you put it all together, it paints a picture of Earth's systems under more pressure, with risks that are getting harder to brush off. The good news? These paths aren't set in stone, and they're still very responsive to what humans decide to do. So what can you and I actually do? I get asked this all the time in the comments. It feels overwhelming when you're just one person dealing with school, work, bills, and everything else. The answer isn't only about stopping climate change overnight. It's also about building resilience for ourselves and our families. Think about it. Right now, stuff happening in the Middle East is making oil prices jump again. That shows depending so much on fossil fuels isn't just bad for the planet. It's risky for our wallets and even for peace in the world. As regular people, we can make practical moves. And if you can, switch to an electric car when it makes sense for your life and budget. Insulate your home better and maybe switch to a heat pump for heating and cooling. Put some solar panels on your roof if possible, along with batteries. The prices for that stuff have dropped a lot lately, and it's getting more efficient. Doing these things cuts your own fossil fuel use, protects you from price spikes, and gives you more control over your energy. And if you live in a place where you can vote, use that power. Look at what candidates actually plan to do about energy and resilience. Small actions from millions of us add up and can push the whole system in a better direction. And there's a lot of concerning new research out there, no doubt. But it's not screaming that catastrophe is guaranteed tomorrow. It's showing us systems under stress and risks we need to take seriously. The same steps that lower those climate risks also make our energy more secure, cheaper over time, and less dependent on faraway trouble spots. I'd love to hear what you think about all this. Do you feel the changes where you live? What actions are you taking or thinking about? Drop your thoughts in the comments. I read a bunch of them. That's it for today's video. A massive thank you to everyone who supports the channel on Patreon. You legends make it possible to keep these videos ad-free and focused. If this helped you understand the latest research a bit better, please like, subscribe, and share it with a friend. Thanks so much for watching. Have an awesome week ahead, stay curious, and I'll see you in the next one. Take care.